In previous years, talking about broadcasting from the cloud has been something of an oxymoron. People were not sure if you could even run simple broadcasts of single channels from there. But it is no longer a question of can you run your channels in the cloud. In today's world, the question is most definitely what do you want to run in the cloud? And Cinegy software forms a large part of that answer. Cinegy have been enabling delivery of broadcasting from the cloud for a few years now and have customers who are running anything from a couple of channels up to complete end-to-end workflows there successfully. During this time, we've learned a few things along the way, and so today I'm going to cover a few topics which we feel can still generate questions from customers and hopefully provide some information which will be useful. Firstly, I will cover what is a cloud deployment using Cinegy? What does that look like? How does it behave? Next, I'm going to move on to talking about tools, as there are lots of them out there which can be used with cloud deployments. I'm going to cover ones which we find useful for repetitive tasks and monitoring of workloads. And finally, I'll talk about some areas which aren't necessarily given the attention they should and can cause issues further down the road. So what is a cloud deployment using Cinegy, I hear you ask? Well, a deployment can vary from a single pop-up playout engine used for special events all the way up to a complete product chain running from ingest using Convert, all the way through management and editing with desktop and archive, to being played out with Air and recorded with Capture for video on demand workflows. And obviously, this is just a diagram showing pieces of Cinegy software, but how does that relate to the cloud? Well, mapping the various blocks of Cinegy software onto some example cloud services shows that for what may seem a complex deployment can actually be reduced down to only needing 4 different capabilities. I've taken AWS services for this example. So in no particular order, we can see that we have EC2 providing the compute requirements, RDS is delivering our database, FSX is acting as the network shared storage, and finally S3 is our long-term media store. As mentioned, so this is only an example, the S3 bucket could be replaced with any source of original media, and Synergy Archive could also be running on a compute instance. One of the areas which we at Synergy get asked about frequently is what sized compute instances are required to run specific player configurations in the cloud. Here are some examples of the types of questions we get. Therefore, I'm going to use the next few slides as an opportunity to give some examples of player configurations with related AWS instance sizes and loadings. Obviously, to carry out these load tests, I need to use a configuration for the player engine, and there are lots of options here. I have chosen a config which I feel is representative of a cloud playout, and this is going to be the base config, which will then be adjusted as necessary with any changes called out. Let's quickly run through this config. I have an instance name set, and under licensing, I have simply added the Synergy Air Pro control option. Moving on to the playback tab, I have one channel with a single IP output added. I've selected the available NVIDIA GPU to be used as my video effects accelerator, and I have a buffer of 50 frames in RAM. The feedback video will be encoded using Synergy's Daniel codec. The single IP output is running in unicast mode, and it will act as a listener for SRT on port 6001. I haven't set a passphrase to encrypt the SRT output. Running the engine in this mode allows me to reach out and request a stream, and I only need to worry about opening network ports on the firewall in this environment. I'm not going to be creating any custom output rasters, nor am I changing any of the default transport PID settings. I've chosen to encode my output using H.264 offloaded to the NVIDIA GPU. This will be encoded at a bit rate of 10 megabits per second, with the various GOP structure set to IBPP and the various other settings as seen here. I am including a single stereo pair, which will be encoded as MPEG layer 2 at a bitrate of 192 kilobits per second. Finally, under the CG tab, I have enabled the Synergy titler engine to allow any graphics branding to be utilized. Okay, so before we turn on any air engines, let's have a quick look at how the machine is sat at basically idle. So we can see we've got a CPU load of around 10% on average, and the GPU is sat there just trundling along at about 6%. Okay, so taking a look at the loading on the AWS instance, we can see the CPU utilization is hovering around 30%. And if we move over to have a look at the GPU, we can see that the video encode is averaging sort of around 18%, moving up and down a little bit either side. Obviously, please bear in mind that these figures are being affected by my RDP connection into the machine and having to render the graphs, etc., that we are viewing. Okay, so having moved up to two HD engines running with two simultaneous HD outputs, we can see that the CPU loading has increased to, on average, 50% utilization. And moving over onto the GPU, we can see that the video encode has gone up to, on average, about 30%. So not quite a doubling of load. Okay, so here we are again, now with three channels running on this machine, and we can see the CPU load is hovering around 73, 74%. So it's getting quite high now and probably going to prevent us from adding any more channels to this machine. The NVIDIA GPU is doing well. The NVIDIA encode is averaging around 40 to 41% utilization. There we go. Here are the results. We started with around a 10% CPU, 6% GPU utilization, and as we moved up, adding more channels, it was the CPU that was topping out at an average of 72%. The GPU was only 42%. And this goes to show that we can deliver three simple HD channels from the smallest of the older G3 AWS instances, the G3S. So, could we fit any more? We could probably fit another HD channel onto that instance by carrying out some additional optimizations and moving some of the load off of the CPU onto the GPU. To minimize our use of what is a reasonably low amount of available CPU power, we could have ensured that our playout media was encoded as a GPU codec, such as H.264, and therefore can stay within our GPU pipeline within the Air software. We could have also removed the feedback video from being generated. This will reduce some of the load, but needs to be balanced against operators' requirements. And finally, one of the other things we could do would be to move the player engines over to run as Windows services. And this removes the requirement for the playout dashboard application to be running and also no longer requires the machines to be logged in. So that was G3, which is an older generation of the AWS instances. Could we achieve more with the newer G4s, which are only ones available in some of the newer data centers? Possibly, but the challenge here is that because NVIDIA have removed support for interlaced encoding on H.264 in their newer chipsets, we need to move to a progressive output. So is this going to offset the newer hardware in this instance? I've repeated the same process as before of adding engines one at a time, so let's see where we end up. Okay, so here we have the AWS G4 instance. I'm currently running three HD channels in 1080p 50 with three SRT outputs connected. As we can see, the loading is actually not too bad. The CPU is averaging about a 60% load, and the GPU, which is the newer Tesla T4, is averaging about a 40% load on the video encode. So here we are with four HD streams running simultaneously from this G4 instance. And here we can see the CPU is averaging about 80%, holding strong. And if we look at the NVIDIA card, that itself is running the encode load at about 54, 55% on average, which is pretty good. There you go. We could achieve more with this instance even with a move to a progressive output. We started with a baseline a bit lower than the G3, 3% CPU, 1% GPU utilization. And as we increased up to the 4 HD channels, our CPU moved up to about 83%, which is slightly higher than we had on the G3, but still an acceptable load. The GPU was averaging around 54%, which again is an acceptable load on that GPU. And these are good results and do show the benefits of using the newer hardware platform. But don't forget that this is still the smallest of the available G4 instance sizes available. What about when we add graphics into the output, I hear you cry? Well, simple elements such as ratings and logo bugs use image files such as PNG, and as you can see here in this example, they will not make a noticeable difference to your instance load. But what about more complex graphics, such as, say, an animated lower third? As you can see, when the graphic kicks in, the GPU load goes up to about 18% and the CPU load goes up to about 29 to 30%. Once the graphic is finished and clears, we can see the GPU is back down to the 13% before and the CPU dropped down to about the average 20-22%. So we did see a load increase on the machine when the lower third animated graphic ran. When the graphic engine first initialized, the CPU load went up to about 42%, but then reduced back down to 30% whilst the graphic ran. The GPU load goes up to about 18% before again reducing back once the graphic is cleared. Now we come to UHD. Is this going to be a challenge to deliver? Here are the changes I've made to the engine config. I've simply moved the player mode up to UHD, and I've increased the output bitrate to 35 megabits per second, but still as a H.264 encoded stream. So let's take a look at the loading. Here we have the G4 AWS instance playing out my single UHD channel, and at the moment you can see the CPU load is going up and down around 30%, and the GPU is staying around 14% utilization. You'll see the CPU load now is reducing down to 16-18%, whilst the GPU load has increased slightly. This is because I've got two different encoded video clips being used in my playlist. One is encoded using ProRes and the other is HEVC. And as it moves between those two different encoding methods, the loading on the machine will vary accordingly. As you can see, the answer is no. With my sample media files loaded into the playlist, we saw the CPU loads go up to around 50% and the GPU average around 14% utilization. As I mentioned, the variance we'll see up and down is because of the two different codecs which the media files are encoded as. And don't forget that this UHD channel was still running on the smallest of the G4 instance sizes available. Right, I hope you found those numbers and examples useful, and I feel they go to demonstrate once again just how efficient and flexible Cinegy software is. Whilst I could spend the entirety of my time showing you even more player configurations and loads, I'm sure you can trust me when I say that it is possible to run more than one UHD channel on a single instance. Therefore, let us move on now to talking about tools and which ones Cinegies have found to be of great use. The two areas I'm going to talk about are automating deployments and that old classic, monitoring. Migrating workloads to the cloud requires testing and investigation. You have to run the same tests in different configurations in an iterative manner. And having a development environment and a staging environment are good practice. Being able to quickly create and delete them to allow fresh testing is extremely useful. Now, whilst the cloud providers have their own automation services, we always prefer an agnostic solution, and Terraform is a brilliant one. To quickly quote their website, Terraform is an open source infrastructure as code software tool that provides a consistent CLI workflow to manage hundreds of cloud services. Terraform uses various types of files to contain the information needed to deploy the elements which make up your environment. Here is a sample of the contents of one of the files used in Terraform. Here you can see how we are defining a G4 instance type, which will deploy into a subnet, given a name, and we use the Amazon Windows Server 2019 image as a starting point. Terraform allows you to document your infrastructure as code and keep this information in a version-controlled repository such as Git. By documenting your environment using these tools, you can easily create with one command and then delete them with the other. This is because Terraform keeps track of what it has deployed, and this is especially useful in cloud environments. No longer do you need to remember in which order you have to deploy certain services, and that you need to create an Active Directory before you can create your database. We have used this tool many times, and it is our default way now of deploying anything into a cloud environment. In fact, our esteemed Mr. Cacaldi even has a video on the Cinegy YouTube channel showing him going from nothing to 150 player channels in 10 minutes, so please take a look. So moving on now to monitoring. As I mentioned when I was showing the resource utilization on the instances, the act of me being connected produces additional load on the machine. We at Cinegy have talked before about big data and analytics, and these once again prove invaluable to not only providing real-time information about the instance, but also historical information to spot trends. So using metric beat to deliver data into an Elasticsearch system and then using Grafana to visualize this is a great combination. Oh, and did I mention it's free to use? So what does this magical combination of software create for us? Well, this image here shows the type of dashboard you can build with this data and shows the insights you can get into how your system is running. Here we can easily see how our GPU is handling the load across the top, and if we want to get some more detailed information about the CPU, etc., we can hover over any of the data points on the graph to see point-in-time statistics. Can we get more, I hear you say? Well, yes, in fact, you can. With Synergy Air version 15, we've added metrics which we believe are useful and can be queried and sent to Elasticsearch. Taking these stats, we can create graphs which show information like this, where we can see if we've had any drops of output frames reported, along with any variations in system timings, and if we're having any delays accessing any media. Then we can combine the information from both Synergy Air and Metric Beat, and this can give us a complete picture of both the machine and the software. This way, if we can correlate if we get an issue with what was happening on the machine at that point in time, which is invaluable when you are dealing with an environment such as the cloud, where you do not control the underlying infrastructure. So, that was a brief take on the tools which we found to be invaluable in our time with the cloud. Let's finish off with some time spent on consideration. What are some things which you need to think about when you are using the cloud for broadcast? If you are looking to achieve maximum density and therefore least cost per channel of playout, then what do you need to think about? Well, source media encoding. Try and have a fixed in-house format which is GPU friendly. You get the same GPU capabilities from a G4 instance type, whether you start with the smallest extra large at say 84 cents per hour, all the way through to the 16x large at over $8. Graphics. Be efficient in how you build your templates. Don't use full-size raster plates to put a bug in the corner. Don't use full raster videos to put an animated lower third on. Hybrid deployments. Don't be afraid of keeping some things on premise. It can be useful when you need to convert signals back to baseband, or if you want to use our new pseudo interlace mode in Air 15, and you want to use one of the newer NVIDIA GPUs in the cloud, you need to convert that signal back to interlaced when you get back to your delivery premise. Split the load. You can use all our software in a client-server mode, which means you don't need to squeeze both your player engines and your operator software on the same instance. You could even run it on-prem if needed. Be mindful of the uptime or availability statistics on cloud services. We ourselves have seen things like AWS's FSx service become unresponsive for up to 20 seconds when a network reconfiguration event occurs. You need to plan for failure when you're working with the cloud. Unforeseen costs. Make sure you are tracking your costs for cloud usage and are aware of when you need to pay to get things either into or out of an environment. If you're using remote operator machines on premise, then delivering the confidence streams to them will cost you money. So just a couple of reminders now to finish. If you need help when you're looking to make the leap, then the Synergy Professional Services team are here to help. And if you're now keen to get started, simply search for Synergy or Channel in the Cloud on the marketplaces in the cloud. I'd like to thank you very much for taking your time to listen to my presentation today.